So here is a question for you. The speed of a nerve impulse in a human body is about 100 meters per second. If you accidentally stab your toe in the dark, part 1, estimate the time it takes the nerve impulse to travel to your brain. Assume you are 1.6 meters tall. Part 2, what would happen if the speed of the nerve impulse was much lower, say 1 meter per second? Okay, so it's just a matter of estimation. So we are just trying to estimate. We are trying to estimate the time which is going to take for the nerve impulse to travel to your brain. Now, the good part of this question is that we have been already given the distance. Okay, so if you want, you can come up with a free body diagram where you say this is a person. Okay, so here's a person. So this person is walking, then accidentally this person stabs um, the toe here. Now they are saying that the speed of the nerve is about 100 meters per second. Then the distance, as in how tall this person is, which you can just say it is the distance, it is 1.6 meters. So we need to find the time. So speed is distance over time. We have the speed, we have the distance, we want to find the time. So what we are going to do is we need just to make time as the subject of formula. We cross multiply, we're going to find that s speed times time is equal to distance over speed, we divided by speed. So t will be equal to the distance over speed. We can now plug in the values. We'll be able to find that time will be equal to the distance is 1 meter, 1.6 meters. The speed is 100. Okay, it's 100 meters per second. So meters and meters will cancel, therefore will remain with seconds. So we can say that 1.6 divided by 100, which is 0.016 seconds. So this was the time it took for the nerve impulse to travel to the brain. So this is the answer for part 1. Then part 2 is saying what would happen if the speed of the nerve impulse was much lower. Let's say it is 1 meter per second. Now we can only give the conclusion after finding the time first. So what's going to happen? So let's say we are saying that distance, we say that distance is equal to we say that speed, we said speed was equal to distance over time. To make t as a subject of formula, we say t was equal to the d over s. Now we have been told that the distance is the same because we are still dealing with the same person. The distance is the same, 1.6. Now they are saying that, let's say now the speed is 1. So time now in this case is going to be equal to 1.6 divided by 1 is 1.6 is 1.6. So we're going to put our 1.6 seconds here. Now it's just a matter of comparing. At first, when the speed was 100 meters per second, the time reduces. So it's going to take a lot of time for the nerve impulse to reach to the brain because we have reduced the speed. The moment when we increase the speed, the time is going to be reduced. It's going to take less time for the nerve impulse to reach to the brain. But the moment when we reduce the speed, meaning that it's going to take a little bit time for the nerve impulse to reach to the brain. So now they're saying what would happen if the speed of the nerve impulse was much lower, let's say 1 meter per second. Now the conclusion is we need first to find the way we have found here. We have found that the time is, when the speed was 1 meter per second, the time is 1.6 seconds. Now we come up with a conclusion to say it's going to take a lot of time, okay, for the nerve impulse to reach to the brain, or it's going to delay, or the nerve impulse is going to delay for it to reach to the brain. That's all. Okay,